Thank you and good morning. I'm André Beijen from KPN, the Netherlands. I'm head of network innovation, and so far there are excellent speeches about the future. What I want to do today is take you back a little bit into the past and take you into the delayering and deboxing of the networks. So first, I want to take you, give you a little bit of insight in what KPN is. And KPN is the incumbent telecom provider in the Netherlands. So we have mobile, we have fixed, we have television, we have enterprise market. And these are our numbers. But what I want to especially point out to you is our TV numbers. If you see in the left bottom corner, we have approximately 2 million TV users. And what's interesting about TV is that it used to be broadcasting. So everybody will sit at the TV at the same time with a plate on his shoulder watching football. But in the recent past, people started changing their behavior on TV. And one of the things mentioned earlier today was that people can use any device at any moment, in any place, in any location. And that changes the way the network reacts to content. So from a broadcast perspective, it was relatively easy. But now you have all these different unicast streams. So the number that is particularly of interest is the number we call concurrent users, the 13.9% that you see in the left bottom. If this number goes up, then you have huge traffic expansion in your networks. And that's the number we watch closely. So the average bandwidth is now 3.7 megabits per second for a TV stream, unicast stream. That will increase dramatically when you use 4K TV or even virtual reality. So these two numbers determine how much bandwidth you need in your core networks. We have fixed and mobile. We are integrating these networks, so you also have a change of traffic flows through your network, and I will address that later. So KPN, incumbent, 125 years of history, 125 years of legacy equipment, and now the future. So this is what's happening in user behavior. You can watch whatever you want on any time you want at any place you want. So KPN has its own video services. KPN Play is a over-the-top service that we provide to our customers. We have our interactive television streams. But you also see a shift from over-the-top providers like HBO and Netflix and YouTube. So for us, in the beginning, we had a quality of service stream in our network for our interactive television. And it also changed to internet traffic. So we had to manage the balance between the two. If you see the right picture, you notice that we have an exponential traffic growth. 70% compounded growth is really a lot. And if you do nothing and you just build new boxes, your cost will probably also expand 70% compounded. And that's if your revenues stay constant and your costs go up, then eventually you will die. So we had to figure out a way to accept this growth. We were investing a huge amount in access, in fixed access, fiber to the home, copper access. We're expanding in 4G, 3G technologies. So we provided our customers with bandwidth in the access side, and they started using it. And so our core network was not ready for that. But we also saw some interesting challenges for the future. The network of KPN needs to be more and more reliable because it's critical for some business customers. It's critical for police services, for hospitals, for and even for consumers. If you have an outage at 8 o'clock during a Champions League match, that's critical for some people. So we had to figure out how to make it more reliable and more robust. And the capacity growth was forecasted as enormously. So we need to figure out, okay, how do we going to adapt to all this capacity need? And there was a huge pressure on costs. If you look at the legacy networks, all these different networks which basically had the same functions but were from different time ages, and we also had a lot of acquisitions from other companies, and these networks were still there. So we had a very complex landscape. So we wanted to reduce the number of networks, the number of boxes, etc. So there was a lot of pressure on cost efficiency. Fixed mobile is a long-term, long discussed in the industry. I remember speaking about fixed mobile convergence 10 years ago. And still, we haven't fully integrated our fixed and mobile networks yet. So there's an interesting topic that we need to address. Are we going to put all our access on one core network, or are we going to have separate core networks for fixed and mobile? So we thought about that. Then there is this new thing called virtualization. A lot of presentations already address that, software-defined networking, network function virtualization. But we figured out early that if you see your current complex network architecture, virtualization becomes very, very difficult. So you need to simplify, not only for cost reasons, but to be able to automate it. And that's a huge driver. If you want to be prepared for the future, you need to simplify. So virtualization was a large driver. And the last one is the Internet of Things and the 5G that we see coming towards us. Somehow we need to figure out how to integrate fixed access, which is everywhere, as mobile backhauling for 5G access points which will be everywhere. So there's a drivers for network architecture. So earlier I saw Telefónica present a very interesting picture. I've tried to simplify that a little bit more. So on the left-hand side you saw our previous network architecture. So we had one centralized IP backbone, and we had a huge transport network on Ethernet, layer 2 transport network. And we had this metro core locations that was distributed over the country. And we decentralized our access networks to these metro core locations. Nothing special, I think. Every operator has the same kind of architecture. So we decided to get rid of our Ethernet network. So we integrate layer 2 and layer 3 transport and cut out a whole layer. And we had this continuity and resiliency requirement that stated that if we have an outage on our central network plane, then the whole country is lost on the transport layer. So why not decentralize our BNG functions? So if a metro core location dies, you only impact such amount of customers that are after your metro core. And these two things, delayering and also decentralizing your network functions, was the initial view. So that's what we did the past 3 years. We recently finished. My colleague is here in the audience as well, and he knows how tough it was to. I thought Telefónica calls it the fusion program, fusion project. It's very difficult, so good luck. But it's doable, and So this is our achievement so far. If you look at the green boxes, so far we migrated 2.5 million triple play consumers. So decentralized their network functions, decentralized internet, TV, voice. We phased out a lot of centralized IP equipment and transport equipment, Ethernet boxes, BRSs. We then decided to decentralize our content delivery network. So instead of having two big video content streams throughout your whole network, we located it at 161 locations. So we have content there. And that's a huge cost-saving opportunity. If you decentralize your content, you save a lot of your transport costs. So that was done. 45% of all our unicast traffic is nowadays decentralized. And business customers is always a difficult group. So in consumers and mobile customers, you have huge volumes, but they are not so complex. Business customers, IPVPNs, all kinds of value-added services can be very complex. So we separate them and build separated edges for these customers. Migrated also. So in the next period, we are going to also move our mobile backhaul from legacy towards this new network, decentralized. We try to eliminate all of our Ethernet network equipment that is still there. We are, and these metro core locations become critical now. So if one metro core box dies, then you have a whole region that's not able to do fixed mobile and TV. So your quad play proposition is gone in that area. So we are trying to make redundant network architecture at decentralized level. And the proof of concepts are very promising. So we try to put up more resilience even there. Yeah, and eventually when the capacity grows 70% compounded, you need to also connect your metro cores to 100 gig or even more. Yesterday I saw the 400 gig equipment already there. So eventually you're going to need more bandwidth towards your decentralized locations. So I was asked not to explain to you architecture, but what was the key success factors of doing this? And first of all, I think it was a very high success because of the teams. From the very early beginning, we put our innovational teams, the Huawei teams, the operations teams, the people who are actually going to do the migration, we put them in one team. So the traditional way of working that you do some innovation and then you hand it over to operations, we figured out very early in the process that wouldn't work here. And nowadays that's called DevOps and all fancy names, but it's also doable in network migrations. Work together. Yeah, we had a very high commitment. So at first people thought we were a little bit crazy. So you want to integrate your level 2 and your level 3 networks and decentralize it at one step. That sounded a little bit risky. But we had very high commitment from our own management and also from the Huawei management team to make this work. We located people at one location. That really helped. So they had a lot of time to understand each other's challenges. And we had very close contact with Huawei R&D. And that helped also because you will always see that in the field, the requirements that you set earlier were somewhat different than you experienced them once you roll out. So we thought about all kinds of migration scenarios. And one of the scenarios was a big bang scenario. So switch off the internet for the weekend and then put it back on Monday. we didn't choose for that. We chose a very developed approach. So small steps, a lot of small steps. Learn. So first we're going to build several locations, then we're going to migrate only internet, then we try voice, then we try TV. So build up your competences in your team so they understand and learn what it means to migrate TV customers. That's different than migrating internet customers. So that's how we did it. We worked with a verification of concept. It was a very interesting period. Normally you do proof of concepts, but at this program we thought like the issue will not be the working the working box. That will not be the issue. The issue will be the working migrating box. So in the verification of concept phase, we not only proved the technology, but we proved the migration approach. So we actually tested our IT, our processes, our people, our operational readiness. We tested all kind of things before we started a rollout. And last of all, the support IT. That's a whole different subject. If you look at your legacy IT, you have multiple environments. I was very interested in the Telefonica presentation earlier, where you see all these kinds of technology and all these kinds of IT tooling. I think it's the same everywhere. But what we did here is we thought from a user perspective. So if you have to migrate, you have to do it in very simple IT steps. And then we designed our IT based on migration instead of based on fulfillment, which is traditional. So network provisioning, network management, automated migration. From day one when we started this project, that was a given. We thought if you want to migrate over 3 million customers, you cannot do that with poor tooling. So we put a lot of effort in understanding migration steps and building the technology for it. So in the end of the day, I think it was a quite successful and challenging program, but it was also very insightful because we made clear to our surroundings that network simplification is a prerequisite for the next level of automation. If you look at all the discussion going on in the industry about software-defined networking and network virtualization, I think you first need to clean up your attic before you can enter the new world. Otherwise, you just add more complexity in your virtualization world. So that's why we started so early with this program, not only to manage the ask capacity, to manage the ask cost reduction, but also to simplify and be able to be ready for the next level. So I'm very much looking forward to the fixed mobile integration. That's going to be a challenging, I think, a challenging project also. We have made several steps, so we integrate already transport networks, etc. But really integrating your core networks for mobile and core networks for fixed will help us prepare for 5G and the Internet of Things era that will arise. Yeah, that's it. Thank you very much.